Welcome to the Shikasa Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Toyota, Ford, and Subaru have adopted power split hybrid systems. The transmissions used in these systems are referred to as eCVTs. eCVT stands for Electronic Continuously Variable Transmission. However, the term can be confusing because belt-driven CVTs, commonly used in gasoline vehicles by Japanese manufacturers, are also electronically controlled continuously variable transmissions. This video focuses on the eCVT used in a power split hybrid system, where continuously variable operation is achieved by an electric motor and a planetary gear set. Toyota first introduced this system in the Prius in 1997. Ford introduced a hybrid system similar to Toyota's in the 2004 Escape, but has stated that it was developed independently and is unrelated to Toyota. In 2019, Subaru introduced the Crosstrek plug-in hybrid with a system based on Toyota's technology. In this video, we explore the eCVT and AWD systems used in the Toyota RAV4, Ford Escape, and Subaru Forester. Before exploring individual systems, let's take a look at the operating principle of eCVTs. An eCVT consists of the following components: an engine, a planetary gear set, MG1, which functions as both the starter and the generator, and MG2, which propels the vehicle. MG stands for motor generator. Drive torque is transmitted from the planetary gear set to the differential. A planetary gear set is a type of power transmission device that consists of three elements: a sun gear, a planetary carrier, and a ring gear. We will look at two examples of gear ratio variation using a planetary gear set. When rotational input is applied to the planetary carrier and the sun gear is held stationary, the ring gear is driven at an increased speed. When input is applied to the sun gear and the planetary carrier is held stationary, the ring gear rotates in the opposite direction. In automobiles, this mechanism is used in applications such as step-type automatic transmissions and starter motor reduction gears, among others. Let's take a look at how a hybrid system equipped with an eCVT operates. During vehicle launch and low-speed driving, the engine is stopped, and MG2 operates as a traction motor to propel the vehicle. When the vehicle speed exceeds a certain threshold, MG1 operates as a starter motor to start the engine. Under low load conditions, such as steady speed cruising, the vehicle is driven by the engine alone. When strong acceleration is required, MG2 is activated to assist the engine. During deceleration, MG2 operates as a generator, providing regenerative braking while charging the battery. During engine-driven operation, the planetary gear set functions as a continuously variable transmission. The engine is connected to the planetary carrier, MG1 to the sun gear, and the wheels to the ring gear. The system varies vehicle speed by controlling the sun gear speed while maintaining a constant engine speed. When the rotational resistance of MG1 is high, the sun gear rotates more slowly and the ring gear rotates faster. Reducing the rotational resistance of MG1 increases the rotational speed of the sun gear, causing the ring gear to rotate more slowly. MG1's rotational resistance is controlled by adjusting the amount of electrical power it generates. This animation illustrates the principle of MG1's power generation control. The inverter controls the connection and disconnection of the circuit. When the circuit remains closed for a longer period of time, MG1's rotational resistance increases. When that period is shorter, the rotational resistance decreases. When the generated power is high and the sun gear speed is low, the ring gear speed increases, resulting in a high gear condition. When the generated power is low and the sun gear speed is high, the ring gear speed decreases, resulting in a low gear condition. Because eCVTs provide continuous, stepless control, it maintains the engine within its most efficient speed range at all times, leading to better fuel economy. The Toyota RAV4 is equipped with a fifth-generation Toyota hybrid system, which features a parallel shaft design. The 2.5-liter inline-4 engine is connected to the planetary carrier of the planetary gear set. The sun gear is connected to MG1. The ring gear also has gear teeth on its outer circumference. The outer gear of the ring gear is connected to MG2 via an intermediate shaft gear. The intermediate shaft transmits power to the differential through a reduction gear. The Ford Escape's hybrid system is similar in design to Toyota's. The 2.5-liter inline-4 engine is connected to the planetary carrier of the planetary gear set. The sun gear is connected to MG1. The ring gear shaft is equipped with a gear that is coaxial with the planetary carrier shaft. The intermediate shaft has 3 gears, one of which is meshed with the gear on the ring gear shaft. Another gear transmits power to the differential. The remaining gear is connected to MG2. Subaru Forester's powertrain features a longitudinally mounted engine and a full-time AWD system, which gives its eCVT a unique configuration. The 2.5-liter flat-4 engine is connected to the planetary carrier via a reduction gear. The sun gear is connected to MG1, which is mounted coaxially with the planetary carrier shaft. The ring gear is connected to the intermediate shaft via a reduction gear. One end of the intermediate shaft transmits output to the rear differential via the AWD coupling. The other end of the intermediate shaft is connected to the front output shaft via a gear. The front output shaft transmits output to the front differential. MG2 is mounted coaxially with the intermediate shaft and is connected to the front output shaft via a gear. Let's compare the specifications of these 3 models. The figures in the table are taken from the manufacturer's Japanese and US websites, and have been converted into consistent units. Please note that the motor output for the Ford Escape has not been officially released. Therefore, specifications for the Maverick, which uses a comparable system, are listed. Ford and Subaru use mechanical AWD systems with a propeller shaft, while Toyota employs a dedicated electric motor to drive the rear wheels. Let's focus on the engine's compression ratio. These 3 models all employ Miller cycle or Atkinson cycle engines. Miller and Atkinson cycle engines are types of engines that prioritize efficiency over output. In these types of engines, a higher compression ratio generally reflects a design priority on efficiency rather than output. If you'd like to learn more about the Miller and Atkinson cycles, please check out this video. You'll find the link in the description. Toyota's compression ratio is 14.2 to 1, compared with 13.0 to 1 for Ford, and 11.9 to 1 for Subaru. This suggests that Toyota's engine is the most efficiency-oriented. However, it also delivers the highest output. According to Subaru engineers, they focused on real-world fuel economy over the figures on the spec sheet. However, whether this is true or simply a matter of technical capability is known only to Subaru insiders. As they claim, Subaru's fuel economy figures on the spec sheet are noticeably lower. However, this is partly because the Forester is equipped with full-time AWD. The ability to constantly deliver drive torque to the rear wheels comes at the cost of poorer fuel economy. Next, let's compare the fuel economy of the newly released 2026 Toyota RAV4, the previous generation RAV4, and the Ford Escape. The previous generation RAV4 and the Escape were roughly on par, but the new RAV4 slightly outperforms the Escape across all categories. This was most likely a non-negotiable target set for Toyota's engineers. We can really feel Toyota's determination. The RAV4 uses an electric AWD system and is equipped with a dedicated traction motor for the rear wheels. While this system eliminates the need for a heavy propeller shaft and a PTU, power transfer unit, it requires the electric motor and inverter to be installed at the rear. Under normal driving conditions, only the front wheels are driven. When necessary, such as when the front wheels begin to slip, the rear motor activates to deliver driving force to the rear wheels. When operating in front-wheel drive, the rear motor is not active. However, it continues to rotate as it is back-driven by the rear wheels. Under these conditions, electrical effects generate rotational resistance in the motor. Audi and China's GWM hybrid systems are equipped with a function that decouples the motor from the powertrain to prevent the rotational resistance from negatively affecting fuel economy. Since detailed technical information on the new RAV4 has not yet been released, it is unclear whether it has a similar function. Knowing Toyota, it may well have incorporated ideas pioneered by other manufacturers. The Ford Escape uses a mechanical AWD system with a propeller shaft. It is an on-demand AWD system that transfers torque to the rear wheels when the front wheels slip, and it consists of a PTU, a propeller shaft, and an RDU, rear drive unit. One of its distinctive features is the AWD disconnect function. During front-wheel drive operation, the dog clutch inside the PTU is disengaged, disconnecting the propeller shaft and downstream components from the powertrain. However, the propeller shaft is forced to rotate by the wheels. The RDU incorporates a clutch that disengages in front-wheel drive operation, disconnecting the propeller shaft. As a result of these operations, the propeller shaft does not rotate during front-wheel drive operation, contributing to improved fuel efficiency. The RDU clutch is positioned on the right side gear shaft, rather than between the propeller shaft and the differential. When the clutch is engaged, its operation is the same as that of a conventional differential. With the clutch disengaged, the differential pinions accommodate the rotational speed difference, preventing the ring gear and drive pinion from rotating. During AWD operation, both the PTU dog clutch and the RDU clutch are engaged. This system merely controls the connection and disconnection of the rear wheels from the powertrain, and is not capable of actively distributing torque between the front and rear axles, according to driving or road conditions. The Subaru Forester's AWD system is a full-time AWD system that uses an electronically controlled clutch. Subaru has not disclosed the front-to-rear torque distribution ratio for the Forester Hybrid. Since the gasoline-powered model is officially stated to have a 60-40 front-to-rear torque split, it can be inferred that the hybrid model is similar. In both models, the torque distribution is controlled between 100 to 0 and 50 to 50, depending on driving conditions and road conditions. However, the AWD coupling differs between the hybrid model and the gasoline-powered model. The gasoline-powered model uses an electronically controlled hydraulic multi-plate clutch, while the hybrid model uses an electrically actuated wet multi-plate clutch. According to Subaru engineers, hydraulic multi-plate clutch generates shock and judder during engagement, which made it difficult to fully disengage the clutch. In contrast, the electric clutch enables complete disengagement. This allows torque transmission to the rear wheels to be fully interrupted when rear-wheel drive is unnecessary, such as during steady cruising on highways. In other words, the Forester Hybrid operates as a front-wheel drive vehicle depending on driving conditions, thereby improving fuel efficiency. However, unlike the Escape, it does not feature a propeller shaft disconnect mechanism. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.